Now I need to examine the logistic equation or the logistic function. Now, this is a whole series of equations or functions that model a particular type of growth, and we'll just be looking at quite simple versions of these. Now, they've got this form, y dash equals some constant multiplied by y, in brackets another constant minus y, where both of those constants can't be zero. Now, to solve these sort of differential equations, you're going to need a special procedure known as partial fractions, because as you can imagine, when we go to separate this equation by dividing both sides by the function of y actually has two parts in it. So we end up with a fraction with 1 on the top and something quite complicated on the bottom, and we need to break that up somehow. Now, this procedure, partial fractions, where we split up the fraction, is actually not part of the Extension 1 course. But don't worry, you'll actually be led through the first step anytime you have to solve a logistic equation. It'll start with part A, show that this fraction is equal to these other fractions broken up, and that's quite straightforward. And then from there, you'll know the steps. Okay, so this is how it works. Show that this fraction is equal to this fraction plus that fraction. That's our first step. So in a show that question like this, we'll start with the side that we can do something with. In this case, let's start with the right-hand side, because it's easier to add fractions that don't have the same denominator by just making the same denominator, and that should give us the left-hand side. So you could write out what the right-hand side actually is. To save time here, I think you could just say right-hand side equals, and then go ahead and say, let's give them a common denominator, and then here we've multiplied the bottom by 1 minus y, so we need to do the same to the top, and then we're adding, we've multiplied this by y, so we need to add y. And now we can see that we've got minus y plus y. We're just going to get 1 on the top, and we're going to get that denominator. So that's now equal to the left-hand side. So that's enough. It's quite straightforward, but it just gets that job done. So now, if we don't want to work with this, we can swap it out for that, and you'll see why that works. Okay, so now for part B, we are going to divide both sides by this function of y here. But as we think about writing down this, 1 over everything that we had on the right-hand side, we can actually pause and say, well, no, I'm not going to write that down. Let's have all of this instead, because I can see that that's the same thing from part A. So that leaves us with our dy dx here as well, because we've got dy dx. We've divided both sides by everything on the right-hand side, and that leaves us with just 1 on the right-hand side. So now we can integrate with respect to x on both sides. These cancel. And now when we go to integrate, just take care here. We know we can integrate one term at a time. The first one's straightforward. This is just the natural log of y. But this one is not quite a so-called perfect question. It doesn't quite have f dash x over f of x or f dash y over f of y. Because really, we would rather that this was a negative one up here. And in that case, it means that we're effectively got a negative sign here. So if this was a negative, we would need to make this negative to make up for it. And so now we can see that we are subtracting the natural log of 1 minus y. And anytime you integrate, just differentiate as well, just to double check that it gets back. If I differentiate this, I get 1 over y, great. And if I differentiate this, I get negative 1 over 1 minus y. So subtracting negative 1 would give me the positive 1. So that's right. And on the other side, we're going to have x plus c. Now we can combine these logs. Anytime we're subtracting logs, we can use the law that says we've got the natural log of one of these parts divided by the other, and that still equals our x plus c. And now we need to get this with y as the subject. So e to the power of this whole side is equal to the absolute value of y over 1 minus y, and this has to still have its absolute value brackets. We can change this to say we've got a e to the x is equal to this whole side, where a is going to be positive, because we can see a is just e to the power of c here. Now to drop these absolute value brackets, we can say y over 1 minus y is equal to b e to the x, where b can be any real number. Now you can write this as b is equal to any real number. That's a quick way of writing that. That means it's equal to all real numbers. Now we've got to get this in terms of y. So a little bit tricky here, but let's start by getting rid of the fraction. I'm going to continue on this side of the board. Let's multiply both sides by 1 minus y. So we've got b e to the x, 1 minus y. Now, you might like to do some of these steps in your head. I certainly would leave a few of these steps out, but I don't want to leave any of them out now because I don't want to leave you behind. So while you're learning, do all the steps. After you've done 10 of them and you're like, hey, I can easily cut to the chase there, then you can start to take your shortcuts. So expanding my brackets, I've got this minus that, and now getting both the terms with y on them on the same side. I've got this. And now I could factorise, I'm going to have y out the front of 1 plus b e to the x. And then I can divide both sides by that whole part in brackets. And I get this. Now, this is not wrong, but it's a little bit clunky to have this term with the constant and the x in it in two different parts of the equation. So we can probably tidy this up a little bit. And the easiest way to do that would be to divide all three terms by this b e to the x. So if we do that, we'll have 1 here. Here we'll have 1. But here we'll have 1 over b e to the x. Now that looks awkward as well because we've got this fraction inside fraction. But what we can do with this is actually just rename that and say that this is, let's just do some work on the side and have a look at this. This is the same as 1 over b times 1 over e to the x. And this part is clearly e to the minus x. 1 over b, what's that? Well, b is just a constant, isn't it? So if I've got 1 over a constant, I've still got a constant, but the constant has changed. So I could give this a new letter. I've already used C and I've already used A. How about I use D here? So I can see that instead of using that, I could do a little bit of work on the side here to just consider that what I've got is D e to the minus x plus 1. And this is my general solution now. Now, does it matter what letter you have there? It could be an A, a B, a C, as long as you're clear about what restrictions it has. Now, does D have any restrictions? Well, it doesn't, does it? In the very beginning, there's a couple of things that we should have considered. Whether you consider them at the start or the finish, you just need to check that they're covered. Now, looking for those trivial solutions, those solutions we can spot straight away, we could see way back here that if y is equal to 0 or y is equal to 1, then we're going to have y dash equal to 0. So these two are solutions straight away. Now it's almost like we've got two cases here. We've got the case of having y, three cases. Either y equals 0, or y equals 1, or if y doesn't equal 0 or 1, then we've got this solution here. Because if y was equal to 0 or 1, we wouldn't have been able to have it on the bottom of a fraction like this. So this is our first case, this is our second case, and this is our third case. All right, case 1, case 2, case 3. Now let's consider what would happen here if d actually was equal to 0. Then this whole term would be 0, and we'd have y equals 1, which would be this solution. Well, great. Either we found it at the beginning, or we found it now by saying, hey, d can be 0. That would be fine. How would we get this solution of y equals 0? Well, it wouldn't come out so obviously here. So sometimes these solutions that you spot at the start, you might have been able to get out anyway, and others you wouldn't. This one wouldn't have come out anyway, because we can't make y equal 0 when we've got a fraction with 1 on the top. So looking for these at the start, which I actually didn't do, I frequently do this at the end, even though I tell you to do it at the start, is key, because that way we find all the solutions. And with these sorts of equations, what we frequently get is we get two horizontal solutions. So let's say we've got one like y equals 0 and y equals 1, and they split the solutions up into three parts. There'll be the ones that are between these two horizontal lines, and then there'll be the solutions that are above and the solutions below. And those curvy solutions that are between above or below will be represented by this equation, whereas our two isoclines, our horizontal solutions, will be the ones that really are in plain view right from the start.